thing is just to make sure you understand when the base is less than 1 versus when the base is 1. Okay? So when you're looking at these bases, okay, if the base of your log is a fraction smaller than 1, it's going to be the inverse of exponential decay. Okay? If the base is greater than 1, then it's going to be the inverse of exponential growth. But one of the easier ways to think about that, rather than trying to memorize when it's this graph and when it's this graph, is you can just use some key points. Okay? So the key points that you want to use is you want to use the value that makes the input 1. Right, so when you're plotting these to kind of get the sense of what the graph looks like, again, just like with the exponential functions, you're first going to find your, in this case, it's going to be your vertical asymptote. Your vertical asymptote is going to be x equals whatever the horizontal shift is. So is there any horizontal shift in any of these functions here? Inside applied directly to the x? No. So it's just going to be x equals 0, or again, whatever horizontal shifting has to take place. So in each of these cases, you're going to start with your vertical asymptote at x equals 0. Right, and then you find your key point. So the first key point is the value of x that makes your input 1. So what value of x makes this first input 1? Just the point 1, right? It just plugs right in. It's just x. So you know that your first point is 1. When you plug that in, think about 1/3 to what power equals 1. If you recall how to solve for logs, if you think of this as plugging in a 1 here, the log 1/3 of 1, you take 1/3 to what power is equal to 1? And the answer would be 1/3 to the 0 power equals 1. Okay? So this is your first critical point. It's the value of x that makes the input 1 and then 0. So there's your first critical point. So here we have 1, 0. This is our first critical point. And then the second critical point is going to be the value of x that makes the input equal to b. Okay, because if we then plugged in what value of x makes, or is, do you need in order to make this whole input equal to our b value? The next point is 1/3, right? So if we plug in a 1/3 for x here, 1/3 to what power equals 1/3? 1, right? So there's our second critical point. So these are the 2 points that you're identifying. So if we look at 1/3 and 1, here's our second point. And so this gives you the general shape of your graph, right? It's going to go up here, and you know it's going to have that, that form of the inverse of an exponential. So it's going to continue in that direction. Right? If we do the same thing for b, right? If we take the same relationships, the value of x that gives us a 1 inside is 1. The value of x that gives us the b value is 1/3. So here's our 2 points. When x is a 1 here, 1/3 to what power is equal to 1? 0. And so when you take 1/3 to the 0 power, you get your solution here of 1, 0. And then with the other example, 1/3 to what power is equal to, or 1/3 to what power is equal to 1/3? 1. So if we plug this in for 1, multiply by a negative, we get -1. So those are your 2 points. If you plot these, you get 1, 0, and you get 1/3, -1. And so again, you can see when you fill out the general shape of your graph what this is going to do. Now, does that make sense with the reflection rule that we have for transformations? The negative outside the function is going to vertically reflect it. And so it's this graph vertically reflected, which you see it is exactly. Okay, but if you just plot your key points, you can identify it in that way as well. Okay, for C, here we take what value of x do you need to make this input equal to 1? Again, 1. And the second point, what value of x do you need your input to equal to give you the base? 5. So those are your two key points. So if you test in 1 here, 5 to what power is equal to 1? 0 times a negative is 0. So here's your first critical point. Your next one, 5 to what power is equal to 5? 1 times a negative gives you negative 1. So here's your 2 points, 1, 0, and 5, negative 1. And so here you can see that this time your function looks like this. Okay, and then your final graph here, if you plug in log 2 of x. So again, the value of x to make this 1 is 1. The value of x to make this equal to b is 2. And if you test these, 2 to the what power equals 1? 0. 2 to the what power equals 2? 1. So that gives you your key points, and when you plot these, 1, 0, and 2, 1. Once again, you see the general form. It's going to approach the asymptote. And so this would be your other graph.